I'd like to introduce our very own Orchid Black. And like it's so often, the prophets are not recognized in their home country, okay? Orchid is very well, how do I say that? She's well known as a landscape designer, educator, and activist for CNPS and all native plants and habitats, and well appreciated. And please give her a welcome hand.
So tonight we're down 30% of our hybrid crew. So so if we have technical difficulties, just please bear with us both in the room and on Zoom. We're down 60% because I would usually be also hosting. So hopefully we will be good. And send request. Yeah, I was the host.
Do I allow you?
You guys said yes to like I said, it used to allow us both to be hosts, but it's just not that way right now. Okay, so we're gonna go back here. And this will go away in a minute. And so I have a couple thoughts. And I don't know, 100+ slides. So probably I should just rock and roll and not think. But thank you guys for being here. Soil is my favorite topic. It is. I cannot make the green thing go away, so I'm sorry, but the rest of the things should go away when I stop having my mouse down there. So this is I read this book Dirt in 2010, and I decided that I would just be freaked out for a really long time. I was freaked out for basically 10 years when I thought about soil in America and in worldwide, and we will see why. But this is, you know, we're in a funky place in our democracy, but we always were. And so this letter, I took it from David Montgomery's presentation. I just screenshotted that and took it. But they were wearing out the land already by this time. It took them a couple hundred years to wear out the land, and they had done that. And the reason for the big push east was really about having worn out the soil and not really understanding what it was about. And it's hard to blame them now that we know what we're doing now, but it is a thing. So so still thinking about how we can do better. And so this talk is a lot about agriculture and regenerative agriculture and how we can apply what people learned from agriculture to our soils. So David Montgomery wrote the Dirt book, and then I didn't realize he had written a couple other books, so I guess he was as depressed as I was. And he went looking for people who were doing it right, for whom it was working. And he found them. And it turns out that there are people doing interesting things worldwide, but in America, there was a group of people doing no-till agriculture, and we'll see why in a minute. So a lot of what I'm going to teach you came out of watching hours and hours and hundreds of hours of really badly produced videos from like no-till on the plains 2008, 2009, where people didn't even know that you should show the slides once in a while, not just the person talking. But but in our, I can try, and that should go away, and these other things may also go away, but so so some of these people are Dr. Christine Jones, and I recommend that if you find soil interesting, that you should just watch everything she's ever done. And Gabe Brown, who will explain this much better than I can, and then Dr. Chris Nichols in front of the computer screen. She took some of the first pictures of mycorrhizae, the first electron micrography of mycorrhizae, and Ray Archuleta is also a god. And there's a bunch of other people that we'll see, Dr. Dwayne Beck, Dr. James White, who took some great pictures of exudate from roots. We'll see what that is. And Dr. Glenn Benguff also, actually, Dr. Glenn took the best pictures of exudate, and Dr. James White took pictures of roots eating bacteria. I'm not kidding. And so just wanted to show off some of the, I learned this from other people, just like I learned everything in plants from other people and books. Okay, so whenever we see this slide, we're going to talk our way through all of these things. Do not disturb. Everybody repeat after me. Do not disturb. Living roots in the ground. Plant diversity. Cover the ground. And integrate livestock. I love you. Okay. When you leave, you're going to know these things, and you're going to remember them because we're going to say them a bunch of times. And thing one is do not disturb, and this is half of the presentation right here. And so on our left, we have a no-till ecosystem, and on our right, we have a tilled ecosystem. We can see how different, how much farther the roots go down, how much darker the soil is, how much more randomly it looks, and how many more things live there. And some things we can't see is that because there's this plow pan, water doesn't infiltrate below that pan. So the original sin is the plow. That's it. And cutting down forests. But I always thought, behind man is a forest and before him is a desert. That's an awful one, but really it's the plow. So what does that lead to? 5 billion tons of topsoil lost annually in the US. And where does it go? Mostly to the Gulf of Mexico, or it just blows off. And you can see where the soil is pretty good in the upper Midwest, and where any place where soils were fragile, it's awful. And we can see in the Central Valley that things are going poorly. We're having salinization, and we're having collapse of the groundwater basins and things like that. And those are the price of irrigation. And so we are told about the Garden of Eden. And if you've ever looked at what the Tigris and Euphrates look like now, it's not that great. So why did this happen? Oh, so it's happening everywhere. Obviously the red is the worst, and then it shades off there. But so there's a great quote: man owes his existence to rainfall and 6 inches of topsoil. So we can't keep doing it this way. We're not going to be okay. And there's lots of other reasons why we're not going to be okay, but this is the main one. And we can see that soil is a big part of the carbon issue. But so this is, the Dust Bowl. And then we have I have lots of pictures of this, and there were pictures this year um, in my feed.
No, I'm listening.
Giant dust storms. So, and they keep happening. So this is our fault. Every time we disturb soil, this is possible. This becomes possible. And so, you know, kind of Dorothy and the Wizard of Oz, only in real life. Then we have this other problem that's part of this problem, and that is the percentage of income that actually goes to farmers. So, you know, why do farmers, you know, vote the wrong way? Because life is not actually working for them. They're spending this huge amount. That blue is basically payments to fertilizer companies and giant equipment companies and every other company or that people think that they need in order to have fertility. And so this obviously doesn't carry forward that far, but you can see it's not a good trend. And so if we look at the US farm income, we can see that our farm income is not good either. People are not making money on the farm. And they're not making money on the farm because the soil is not fertile. And so they're adjusting for that in ways that are expensive. And I found this quote, in Kansas, 6,000 towns have vanished in the past 80 years. So you don't need as many people on the farm, and there isn't enough people to support businesses that used to be there either. And I found this book in 2014 and read like the whole trilogy. Okay, so I went through a romance novel thing, but and the major plot point of the book is that corn is good that year, and so the corn price went down, so no one in the community can afford anything. So this is kind of, it's like you know, damned if you do and damned if you don't, or heads I win, tails you lose. If you get corn, then you everyone has corn, and if you don't get corn, then you can't pay for it either. So we're in some difficult places here. Then we always hear that greenhouse gas is really about the cows, and don't ever eat beef. And so someone in Davis put out a story of why that is, and why we think that. Why is eating beef worse than air travel? It isn't. Somebody did some bad math early on and did the entire life cycle of beef and emissions for beef, and then they just did the actual flying miles for airplanes. And then a famous musician, who we all know the name of, is vegetarian and put that out everywhere. And since then, since about 2008, I have seen article after article telling us that we can fly and we can't eat beef. It's not that way. So we can see 32% of greenhouse gases from enteric fermentation. We can go back and look at that. But then 38% of nitrogen oxide from soil management. And what is that? So when you plow, you don't just lose the carbon from the soil, you also lose nitrogen oxide, or nitrogen combined, just like carbon, with oxygen, and then you get another greenhouse gas. And so it's really kind of a complex thing, and so difficult. And so people are like, well, okay, that's fine. We'll just not eat cows. And that would be fine, except for actually fertilizer possibly emits more methane than, 100 times higher than the fertilizer industry's estimate. but also if that's true for this study, that's actually send a Google car out to sit outside of plants and just measure the methane release. So fertilizer is nitrogen fertilizer is made of ammonia and methane, and so the estimate is just, it was just a number picked from air. Someone picked that number from air, and it turns out that that if this team from Cornell is in fact correct, if the emissions that they found outside of fertilizer plants scale to the entire fertilizer industry, that would be more methane than all of US industry. So you can find this, and I have links. If you got the handout, you have these links for yourself. You can go read that. And so what is it? So what it is we have, in the Bible, they had this thing, you could have 6 years of crops and then you had to go to pasture. They kind of forgot why, but soil carbon is why. So you have your pasture phase, and then you have your cropping phase where we can see the soil carbon just plummets. And then if you return it to pasture, it comes back over time, but not that quickly. And so, I mean, what is that? What is that soil carbon? It's when you go into a forest and dig around, if you're the kind of person who like just digs around when you find soil, it's black. When I was a kid, I ran through the forest barefoot, and I would sink into this black stuff. And when there's no soil carbon, you just have kind of a brown or a gray or sometimes a red. And so, you know, when you burn logs, you get something black, and soil carbon is the same way. And but the good news is that you get a lot of benefits when you get soil carbon. And there's more carbon in soils than there is in the atmosphere and in the plants. And so that's the point where I started thinking, okay, maybe we aren't actually in an awful space. So and so what is that? That's 1,500 gigatons of carbon. So there's about 600 gigatons in plants. And the most of that is present in the top 10 centimeters of soil. So so that's what we're looking to fix. And so soil carbon loss is basically plowing. So why do people plow? Because it makes carbon and nitrogen and minerals available to the plant. Ray Archuleta, it's like burning down the house to cook a hot dog. Okay, so he's brilliant, but I try to think, what is really the right way to think about this? And did you ever have that roommate that would like take the last of the milk and never put milk back in the fridge? Right? Or anything. Maybe they were just, you know, and then you have roommates and then everyone has to like write their name on their stuff. So right, so that's what plowing does to the soil. It allows the nitrogen to become more available to the plants, and it allows the carbon to become more available to the plants, but it never puts those things back in. And so if you think about 10,000 years of agriculture, that puts us in a difficult place. If the roommate keeps going to the fridge and pulling the nutrients out and never puts the milk back in, or the, cheese or whatever, it's going to be an empty fridge. And that's kind of what we're staring at for our ag lands right now. And so Dr. Beck, so tillage is another word for plowing. And it basically increases the speed and the extent of nutrient removal, leaving the resource degraded. So this is kind of a difficult thing. So we're kind of not here now, but a couple of years back when I started this presentation, we realized that why don't people do it the right way? And the reason why people don't do it the right way is because it requires farming in a way that isn't insurable right now. So we had some pilot programs in a couple of years back under Biden that were just trying to make crops insurable if there was more than one crop in the ground. And we will see why that's important. And everyone's like, what does this have to do with native plants? But we will get there. We will, I promise. So, so I learned back in the darker ages that soil carbon came from like composting leaf litter and dying roots and things like that. And we can see on our left that that's actually most of that just gets respired out and maybe forms 5 to 10% of humus. And that root-derived carbon sequestration is like 40 to 70% of humus. So we see on the right, it's just darker. It's darker, and we'll see why it's darker. So why do we get more carbon sequestration? And then my other inspirations are Bert Wilson from Las Politas and Greg Rubin. And my students asked us, we were like, oh, you can make soil carbon. And my students were like, how come we don't know that we can do that? How come we don't know that? And I finally realized part of our problem is we just study the simplest thing. And the simplest thing is a plant that is not mycorrhizal. So it's not connected to fungus in the ground. And so it's easy to study. There's fewer variables. And so lots of our brassicaceae are just not mycorrhizal. And so, that's fine, except for, there's probably thousands, if not hundreds of thousands of studies on this one plant because it was a simple system. And we're not in a simple system. So it's fine when you're trying to think simply, but we have to do better. So there are non-mycorrhizal plants that don't connect to fungus in the ground. And so they are Proteaceae and these other listed ones, Chenopodiaceae, and Caryophyllaceae. I just like to say ACE, that's all. And but we can see, and you're welcome to take pictures of all the slides, or probably I would just give you the slides. This will be on YouTube, so don't worry. But so how do we get carbon? So it turns out that plants don't just make carbon to stand up with. They don't just make carbon to make leaves and stems and so on. Plants make carbon and they give it out into the ground to the microbiome. And this is like the big magic trick. This is the best. And so this is the best photo from a guy who obviously is good at this. And so that's sugar syrup from this root, right? So this is a root and this is sugar syrup. And so the plant is not just feeding itself, it's feeding the entire community. And so we'll look at what is that community. And so we have, our decomposing leaf litter, but then we have the CO2 going into the ground, and then it's feeding this microbial community. So all these different microbes. And then it says entombing effect. And what do they mean by that? That basically the microbes come for the sugar syrup and they have a little sugar syrup party and then they die. And that's what soil carbon is mostly from, is dead microbes. They came to the party, they don't live that long, and they're entombed, and there you have your stable carbon pool. Okay. So yeah, so it's a good thing for Halloween. And so our stable carbon pool needs to be not disturbed. We don't want to take our carefully put carbon into the ground and then go after it with a plow or a shovel and let that go back out into the atmosphere. That's not what we want. So, and mycorrhizae, so everyone pretty much has heard this word by now, and there's some great books, and Suzanne Simard, and I forget the name of that other guy, the Entangled Life guy. So now we know we have our sun, and then it shines on our nice oak leaves, and then our oak is connected to not just one kind of mycorrhiza, but just tons of different kinds of fungi, of which we can only make in the lab or allowed to survive in the lab, just a few kinds. So when you go and buy that packet, it's not wrong to go buy that packet of mycorrhiza, but you're only getting one of like hundreds, if not thousands. But here on our other side, we have maybe our bean plant, and it is also fixing nitrogen. And so we have some different things going on. We have our carbon fixing here with the mycorrhiza, and the mycorrhiza are also hydraulic mining the rock for minerals that they trade back to the plant. So this is a big market down here. This is a big trade going on. So some plants fix nitrogen, and then there's free living nitrogen fixers, and then there's fungal partners. And so it really is a big party. And so how come we don't know this? Well, I don't know. I can't see down there. And so soil microbiome, bacteria, fungi, so on and so forth. And then there's other fungi that just decompose things, and they partition the soil, which is really a trippy thing. And then we have rhizobia on some of our nitrogen fixing plants, and so most people think of them as, Fabaceae, but we have a bunch of not Fabaceae in California that also fix nitrogen. And so the rhizobial are mostly for the Fabaceae. So there's even a special rhizobium for lupins that you could buy. Has anybody here ever grown peas? Yeah, so you grow some peas and you buy this little black powder that you shake on your peas. Nobody? Okay, just like 3 people. Okay, so I started out in vegetables before I started native plants. And yeah, if you want to plant peas, you have to plant their rhizobia with them. Yeah. So there's a lupin rhizobial partner too that you could buy. But there's also some free living bacteria. This always was a thrill to me, of things that also fix nitrogen, but they're not part of the plant. We'll see how the part of the plant ones work in a minute. There we go. So these rhizobia, they can't live in the atmosphere. And there is oxygen underground, and roots do respire oxygen. But they have this deal with the plant where the plant protects them, and the rhizobia live in these nodules, and that's where nitrogen fixing comes from plants. So there's a couple of Fabaceae that don't have nodules. I think redbud is one of them, supposedly, but most do. And then we have other things that I have a big list of. So this is, we can have a giant fertilizer plant that's emitting methane, or we can get plants to do it for us. One or the other, huh? And so here we have a list from Las Politas of our non-legume native plants. And so alder and cercocarpus and ceanothuses and bayberries, and a few other things. So it's not just, so you have to think about that. And I have, about 15 years ago, I figured out that I could use alder as a nurse tree for other trees. And so that's a good trick. because they grow fast and they live about 10 years and they die. And so your oak is going to take a long time to get that tall. So you could have a tree right now and then a tree for later. Yeah. So the lumber industry likes to remove all the alder. It confuses them. So the Bible has some issues, but we'll talk about them in a minute. It had some great ideas, but some other problems. And but so we'll go here and we'll think about that later when we talk about the plant diversity part. So here's the actual roots of our pine seedling, right? Where the cursor is. And then everything past that is really mycorrhiza. So myco, fungus, rhiza, root. So I mean, it's orders of magnitude greater amount of root space in the mycorrhiza than there is just in the plant. And in fact, plants couldn't make it onto land without mycorrhiza. A few plants, like our little list of plants that aren't mycorrhizal, did abandon that for a different plan, but for plants to leave the ocean, they had to, or the water at all, they had to have mycorrhizal partners. So this is an old thing. And so then we have, I always love this, vesicular or buscular mycorrhiza. You know, it sounds like tree, right? And what they mean is there's a little tree of fungus inside the root cells, right? Looks like a tree, so let's call it that. I always wonder about those people. They confuse me. But we can see that that blue stain stuff is the mycorrhiza within the root cells themselves and between them. And then we have the other, the kind of that surround the root mycorrhiza that is more so conifers and oak trees. So a different set of partners. And I mean, there's whole lectures you could just watch about all the kinds of partners. But we're not going to go there. We're just going to know that they exist. And then here are, you know, the partitioning of different mycorrhiza in an oak root. So we have our kind of our different ectomycorrhiza, and then the VAM, the little tree mycorrhiza, in below that. So, and then there's also probably a partition layer of decomposers on top. And then there's this thing, so we're like, oh, plants, you know, they just photosynthesize and you know, they're you know, nonviolent. Like, I don't want to get into the vegans in the room, but there's just a lot of violence in plants. And so, and how do we know? Because James White took these pictures of plant roots sucking up bacteria and crushing them and spitting some of them out. Yeah, so yeah, my friend Bruce used to say, oh, little Fluffy is, you know, an awful predator, right? Well, so are plants. Plants are eating bacteria. This is wild. I try not to have, you know, moving pictures in these kind of shows because it's more tech than we can even do, and most people fail at it. But this is a fun thing to watch, and it's on your list of just, you know, let's suck up these bacteria and then let's, you know, the bacteria have the minerals that the fungi provided them, and so it's a whole thing. And you know, people were right when they said ecosystem, although I think they were wrong when they said environment. So glomalin. So glomus was the easiest mycorrhiza to grow. And it was the first one to take pictures. And so we have basically these strands of mycorrhiza. And then around them, the bacteria are actually using these strands of mycorrhiza as a highway. Really, yeah. So there's a whole bunch of stuff going on. And so here are other pictures. Again, Christine Nichols from USDA took all these pictures. And so see all these strands? Those strands are gluing the earth together. So if there's no strands and the wind comes, it just picks up the dirt, and there you have your 5 billion tons of soil loss. But if you have strands of glomalin gluing things together, then the soil isn't leaving. So, and there we have, the soil particles actually glued together around a root. So you can't even see the root, it's just soil particles. And so here we have this picture root aggregate, and then we have this important other picture where they put the seeds in a trench, and at the bottom of the trench they put nitrogen fertilizer. And we can see all these roots have glomalin, and the soil particles are glued to the root. And all these roots don't, because they were in the bottom with the nitrogen fertilizer. And so I like to, I used to get plants from Las Politas at Theodore Payne. I started in plants, or in native plants, by volunteering at Theodore Payne like 25 years ago, almost exactly. And we would get these plants from Las Politas, and they would look awful in the can. They would just look bad. People would not want to buy them. But all of us who were, working in landscape, we would buy all those plants, because if you got them in the ground right away, they would perform. And so, that was kind of, and so what was that about? And so Greg Rubin would go, oh, well, it's mycorrhizae. And we would go, oh yeah, sure. I mean, that's what I would just nod my head. Yes. I didn't know what he was talking about. I just knew it was this magic stuff. But I'd like to say the difference between a fertilized plant and an unfertilized plant is the difference between a lottery winner and a new immigrant who comes to a family. So lots of immigrants come in, and they usually have a family here already, right? And they make connections with each other. And they live in someone's house, and they, maybe ride with someone to work, and someone else finds them a job, and on and on. Or you have whole restaurants that are dedicated to immigrants. And then you have people who win the lottery, and they start dropping their connections, right? They quit their job, they fight with their family, who all think that if they gave them some money, their life would be better, which probably it would be. But they drop connections. And so giving plant fertilizer is kind of helping them win the lottery, right? And so you get great plant for a short time, but it doesn't have these strong connections. It doesn't have the mycorrhizal glue around the roots. It doesn't help stabilize the soil. It's not getting these extra minerals that the mycorrhiza would bring it. So that's what a native plant especially mostly needs, is to have all those different connections. I mean, we need them too, but we can see it right here in this picture. We have our lottery winning roots. They're not going to make it as well as these other strong internal connections and external connections roots. And I stole that picture from Christine Jones. I hope she doesn't mind. So then we go into the fungal bacterial ratio, and everyone's like, hey, I was told there would be no math. Yeah, so there is. So first we start with lichens. If there's a disturbance, a flood, a fire, landslide, what you get first are annual weeds, or usually lichens, and then annual weeds, and then perennial weeds, and then shrubs, and then smaller forest, then larger forest, or for us, chaparral. And we have another one, bacteria over here and fungi over here. So the fungal bacterial ratio is either you have lots of bacteria because you have early in succession, or you have mostly fungi. So what we're looking for in our system is to have mostly fungi. And when you don't have mostly fungi, what you mostly have is mustard, because mustard is working in a bacterial system. And so like 10 or 15 plants for vegetables that we use are all like one mustard, right? I'm not going to list them all. You'd have to trust me. You can take my class if you want. And so, but some of our vegetables do like to have mycorrhizae, but some of them don't need it that much. So then I like this one the best because it's really a good explanation. And I know this is dense. I know this is dense, but we start with, our landslide rock, and then we have, that cyanobacteria that might be your desert crust, and a few fungi and a bunch of other living things. Then we have, weedy grasses mostly. Then we have our slightly more mycorrhizal grasses. And so our fungal bacterial ratio goes more to fungi as we go up our chutes and ladders game. So then we get to our mid grasses and legumes, also, clovers, and then row crops and some native plants. And these were mostly made in like, the Midwest prairie. And then more natives. And then our natives are really up here at 5-to-1 or 100-to-1 fungal to bacteria. And in fact, if your ground is really struggling, you can just go to the forest, grab a teaspoon of soil. And I've done that for Arctostaphylos, for manzanitas. Get a manzanita and it's struggling in the ground, and I'll go and take like 1 teaspoon of soil from a happy living manzanita, because manzanita have their own mycorrhizae. So what does this whole our chutes and ladders game mean here? So what it means is most of us are actually starting here. If you're starting with a new garden, you're starting in we had to do something to get the grass out. We had grass. And so there's less oxygen, there's more bacteria, and there's not too many fungi. And then we go on and maybe we have, California brown or bad browns or Bermuda grass. So on our left over here in the bare parent material, that was our disturbance. So whenever you disturb, suppose we go and cut down all these trees and then run some heavy equipment to get the logs out. We can take this 100 or 10,000 to 1 and send it right back to 100% bacterial. So it's easy to go backwards. All we have to do is disturb. And so, but then, we can get to these other interesting places where we can start our native plants. And some of our wildflowers are really not mycorrhizal either. They're as early successional plants, like we saw in our couple of slides. And then up here, we have our good, happy native plants. It says deciduous trees, but our plants are really up here in the close to the top. And so that was kind of, so like I said, we could make a chute backwards in our board game just by disturbing too much. Or we could make a ladder by not disturbing, by covering the ground, by planting diversity, by keeping living roots. So these really are choices that we can make, and we can get to where we want to be pretty quickly if we make those choices correctly. So, and then to get from here to there, you have to really have had a plan. But you can, and so we'll see what that plan is. And so here's an early study about this in 1994. And when we think about that, we realize also that Chris Nichols was just taking those pictures right around then, those first early pictures of mycorrhizal. And this was mustard infested beach. And we can see that tree of life and David Pryor. And a bunch of people figured out that they could take out the mustard and add mycorrhizae and make imprints with the soil imprinter to hold some water and have an early successful restoration just based on what they were doing with the soil. And so this is, of course, very inspiring to all of us. And it says, it was a stand of black mustard that was, 6 feet tall. But they had a plan, and their plan was, how do we think about soil? And so, and then people are like, well, but what about the roots? What about the roots? So water is powerful, and water inside roots is really powerful, and it can break rock. And you were like, okay, well, there's like 50 of these photos on the USDA, on the Forest Service website. But this is my photo of some, I think this was bumblebee penstemon just growing right out of the rock. So mycorrhiza will do some hydraulic mining, and then roots do the rest of it. So if you have a microbiome, you can grow right out of rock. Doesn't have to be, no one has to till that for it to work. So we're back to here. Do not disturb. Living roots in the ground. Plant diversity. Cover the ground. And integrate livestock. You guys are awesome. Okay, so living roots in the ground. This is not where this was when I learned it, but I decided that really it's the most important thing after don't disturb. And the reason is because you need to get those sugar syrups into the ground so that the microbiome can grow. And so farmers assumed that every time you had a crop, it was taking away and never giving. And that turned out to be the exact wrong thing. And so people started working. There is a government program that teaches people not to do that. And so that's living roots in the ground in agriculture. And then we have living roots in the ground in the desert. And so maybe 2014, I saw Mike Allen at a CMPS meeting. And he's talking about the giant pool of stored carbon that has the potential to be lost through anthropogenic disturbance and exposure. So this is a paper, really, why not have solar in the desert, that the Energy Commission commissioned from Mike Allen and a bunch of other people. And here's why. So you would think, okay, well, all this sugar syrup going into the ground, that's not doing anything in the desert. But it turns out that what happens in the desert is that there's lots of calcium because they were inland seas at some point. And so desert plants have mycorrhizal partners that grow limestone, so calcium carbonate. And the important thing for us is the carbonate part, is that these roots are just fixing calcium carbonate in the desert. So if you've ever wondered what that caliche layer is, I'm digging at my sister's house in Tucson, and I'm like, what's this about, this layer of caliche? I mean, I don't understand that. And the plant roots put it there. And so this was, this was them with a USB microscope and some duct tape. My partner was next to me saying there's always duct tape. And these are making carbonate crystals underground. And I think that really worked as an evolutionary strategy. Part partly because it helped perch a water table for the plants. And so we have another one. So when someone says, oh, solar in the desert is renewable, there's just no gain. There's no, if you don't have the living root, then you're not fixing the carbonates in the desert. So, yeah, solar panels belong on their roof. They don't belong out here. So we can see on our left our crystals again. And then we have, you know, what the land does. And I would go out driving with Bruce, and we would look at flowers, and he would be able to point out areas of disturbance that didn't look disturbed to me. And I finally realized that he was looking at the landform and going, oh, this area was dist. Even though it was just all cows. But after a while, I started being able to see that a lot of those areas come back in Amsinkia, fiddleneck. And so here we have an entire field of Amsinkia that I was on the way to have dinner with some people, and I just stopped. You know, I was a half an hour late because I had to take pictures of Amsinkia in this field. So the field has a plan for fixing itself, and it is this. And so this is the same thing. Here's a dist area west of the Carrizo Plain, as we can see in the background, and it's almost all Amsinkia. So that's another plan for how do we solve the soil problem? How does soil express its problem? And then we have this other, so around this oak tree, there was this area of just bare ground that wouldn't grow anything, even if they planted it and watered it. And so I thought about this and I thought about this, and they were like, can anything grow? And I'm like, well, we could put some phyla nodiflora. So some of it's native and some of it isn't, and some of it is called Carapi, and it's really not native. But it occurred to me that it would, one, cover the ground, and two, it would pump a lot of syrup into the ground right now. And it did. So not only did it cover the ground and this area that was all just the same brown where nothing would grow, that it just erupted in everything that's ever been there. So it was juncus and it was columbines, and the people actually were not prepared for this. And they cut it all back. And I didn't really have the contract for that, so I wasn't going to go in and weed it for them. But I'm really sorry that I didn't, because the soil just started expressing, you know, riparian plants. And here's just another some Point St. George aster in the rocks. Just another, you know, nothing will grow here. Well, let's just start something growing here. And so that's the other thing. If nothing grows there, you need to get something to grow there. And that seems like, you know, it's kind of like pull yourself up by your bootstraps. But especially our wildflowers will do that. So then we are here, you know, do not disturb, living roots in the ground, plant diversity, cover the ground, and bunnies. When I was a kid, there was bunnies everywhere. So plant diversity. So Greg Rubin would talk about the whole mycorrhizae and not fertilizing and mulching heavily. We'll talk about that. And sow some annuals to reset the system. And he was like the most, like his landscapes were successful, and he knew why. He knew what to do to make them work. And everyone else was like, oh, you can't plant in summer, and he planted all summer. And I was like, that will work for me since I was working. And so we'd put in the plants and then put in the mulch and then throw a bunch of wildflowers. So it turns out that that is the right answer. And so the right answer is that one plant at a time doesn't bring enough of the microbiome. So basically, if you're pouring sugar syrup into the ground, you have a bake sale. And so when I go to the bake sale, I eat the brownies. And when someone else goes to the bake sale, they eat those Rice Krispie treats, and someone else, right? I came up with this on my own, but someone, a famous soil scientist has the same metaphor. It's basically that different microbes come for different flavors. And so if you just only have one flavor, you only have one kind of microbe. And sadly, the Torah said you can only plant one kind of plant in a field. So between the planting and the only one plant in a field, we kind of went the wrong way for a long time. So we have the Jenna experiment where they just tried to work out how many plants have to be in a field for it to be resilient. And this has been going on for decades. And turns out it's like 8 different plants at minimum, and maybe 8 different genera if you really want to be real. And so Gabe Brown, we saw him before. And this famous Brazilian scientist, I think his name is Ademar Caligari. And so he had this idea that you did really need diversity in your field. So they did this experiment in 2006 of contiguous fields, just turnip by itself, oilseed by itself, triticale by itself, and this cocktail. And then they had a month of drought. And everybody would say, well, if you mix things up, then this plant is taking from that plant. But we can see our turnip field is struggling, our radish field is struggling. Again, they're brassicaceae, so they don't even have the mycorrhizae to help them. And then we have our 8 plant mix, which is doing fine. And a whole bunch of people in the Midwest went, oh my God, we have to do it this way. And of course, no one did it that way, and it wasn't the right way. And so it was mostly people who didn't grow up as farmers or were willing to tell dad that we were going to do it a different way. People ask me, why don't farmers all do it this way? And it's because they're betting the farm. And if you do what people always did, no one's gonna go after you if you lose the farm. But if you do something new and you lose the farm, everyone's gonna hate you forever. So the microbiome does know when there's no plant diversity. And apparently also your belly microbiome knows if there's no diversity. So people have said that you need like 30 different plant foods a week for the microbiome to know that there's enough diversity. I don't know if that's true. But diversity above and below ground creates soil carbon. So I love these people. They're listed in your handout. So they have basically 1 + 1 makes 3. So if you just have one kind of plant, then you have just one set of microbes. And then if you have 2 kinds of plants, you get, triple the kinds of microbes. No one knows why, but this is why. So so it was nice of them to put this nice slide together for us so that we can think about this. So then we have another nice release there, not just we get things, we don't just get plants, but we get everything else. And then, this just looks from a distance like it's poppies, but there's a whole bunch of cryptantha and, lupins and a lot of other things are in this field. And then we have the Tejon Ranch, and again, a whole lot of things, different things are in this field. And the Santa Rosa Plateau. And here we have a lot of Amsinkia in a place that was also dissed on the Tejon Ranch. And then our plowed field in the distance. Ooh. And so happy diverse plantings are what we're looking for. And then we have the green cover seed who's put out some of these kind of things. What does it take to get, what kind of mix do you need to have good agriculture? So, different people have studied this, and William and I started thinking, what do we need? So So you could mix different things for if you want to grow vegetables. And my friend turned his awful clay soil at the Learning Garden into soil you could stick a whole hand into by planting alfalfa plus sunflowers plus flax. But William and I started thinking about this 8 families or 8 genera. And, I would just usually tell people, oh, pick your choice of the rainbow mix or the blue and gold mix, because you could just get them. But then we started thinking, what really is it? And so I made a big list, which is in your handout. People online, that this same soil handout is, we will put it on the website. And it's also on nativesanctuary.wordpress.com. But so Achillea, deerweed, Sinkia, Cucamonga is just a strain of California brome. Clarkia unguiculata. We try to think of things that would grow pretty well together. And so I think if I were making my own mix, this would be my mix. What I don't see actually in people's gardens, especially on the garden tour, is not enough Phacelia. There's Phacelia everywhere, but there's just not enough Phacelia in people's garden. Here's above Lake Matthews. So we have our shrubs, but then we have quite a few annuals mixed in, and that's what we're looking to do when we're planting a garden. And then these people were good and they sowed the annuals every year. And I finally just recently heard Greg Rubin, and he was like, oh yeah, so your spring annuals put the carbon in the ground for your summer blooming shrubs. So your buckwheats, your salvias, things like that. So you can't just have your shrubs, you have to plant your annuals in between them. And not just that first year, every year. So, because just one kind of plant isn't going to get it. Okay, do not disturb, living roots in the ground, plant diversity, cover the ground, and bunnies. Just because, we can't have antelope or bison or whatever, but there was always bunnies when I was a kid. So, microbes really like this kind of the same temperature that we like. So if you have living plants over soil plus soil residue, you can have like 90 degrees, or some crop residue, you can have 100 degrees. So keeping some mulch on the ground is important. You can have too much mulch, or your mulch can be too wet and bring ants, but you can't have no mulch unless you have all desert plants. Or all, oh, this is unhappy. Oh, you feel better now? I hope. So ideal soil temperature is 70. I like that temperature myself. And apparently microbes are pretty happy with it. So in this system, they just knocked down the rye and then planted the soybeans into it. So that's another thing. You can cut down all your annuals, or you could just knock them over and use them for mulch. And then here are a few studies about that. Conversion from sage scrub to grassland enhances decomposition. And that UV was the most important factor for decomposition and carbon release. Basically, if you don't cover your ground, then what happens? The carbon goes away because your mycorrhizae cannot grow in too much UV. So that's an issue for how to have grass. So here we have a cardboarded system. Instead of digging out your Bermuda, we just cover it with cardboard and mulch, or mulch paper usually. And then do not disturb, living roots in the ground, plant diversity, cover the ground, and bunnies. Okay, so So some of you probably have seen the, Carbon Cowboys and Kiss the Ground, and people just figured out, maybe 5 years ago over time that there's often more carbon in prairie soils and grassland soils than there is in forests. And a bunch of people inappropriately started thinking we would make grassland. It's like, yeah, you can't have a grassland on top of that hill in Pomona. I didn't say that to the woman who was planning to do it, but I also couldn't come to her and say, you would need some bison for that to work, right? Or bunnies. I'm thinking about a bunny tractor. It would be a business, like those people with goats. Somebody should do it. But so we've all seen like really degraded land with cows on it that turned into mustard or turned into grass. And so there's a right way and a wrong way to have cows. And so the right way is mob grazing, where they move the cows really often as if there were still wolves or lions or whatever in the area. And so all the bison or the bunnies or the cows or whatever, they get one bite of grass and they keep moving. If cows are allowed to just spread out on the landscape, they can degrade the landscape pretty quickly because they'll eat their favorite plants to the ground. And so integrating livestock really has to be done thoughtfully. But we have, dryland landscapes, we have areas that were grass and were herbivores and then became desertified when all the herbivores came off of it. And people have reversed the process also. I mean, I'm giving you like this little glimpses into this whole giant field. But it is a field that people are taking really degraded landscapes and fixing them with intense animal production, but it's moved really quickly. And they are people that usually have a botanist, or they are a botanist, somebody who can see what is growing. So here's, Antelope Valley with antelopes. And so that's our factor. So we have a few movies about this. If you want to watch them, I suggest it. People are fixing carbon by ranching. So, I mean, how many regenerative agriculture farms are there? There's about 1.5% is the number that I came up with today. But that doesn't mean that we don't get to have it. We can have that. I buy regenerative beef. You can get regenerative dairy in California, Alexander Farms. It's not you can tour these farms. And you can do it right in your own garden. Okay, so do not disturb, living roots in the ground, plant diversity, cover the ground, and bunnies. Okay, you guys, thank you.